great start for my first YouTube live in more than 2 years, but good afternoon, everyone. Hopefully you can all see and hear me now that I've pressed unmute. And welcome to the M Word, our new live episodes, which are going to air every week for about 15-20 minutes or so. We'll keep you updated on our YouTube and social media channels as to which day. Next week, for example, it's Monday. But the idea behind these sessions is to have a virtual coffee break, really. Cheers. And chat about all things Autodesk technology, industry, tips, tricks, what's new, and what news is out there at the end of the day. So firstly, these sessions we want to run for you guys. Please get involved. Please remember to like, remember to share, remember to comment, and obviously give us feedback as well. Would love to hear what questions you have or what problems you're having inside of Revit or Inventor or AutoCAD or even with industry topics such as digital construction or building information modeling. We'd love to hear from you so we can try and make these sessions as interactive and interesting as possible. So hit that like button, hit subscribe, and if you hit the little bell that pops up, it will give you notifications for when we go live as well. Great to have you on board. So a little bit about us before we get started. If you haven't heard of us before, we are Man and Machine. We're an Autodesk Platinum partner, which essentially means, if we get all of the fluff out of the way, that we sell Autodesk software and the services to support that software, including training, including support, and the wider BIM consulting services as well, which come with the need to work in the digital construction space. So we've got a great team of individuals here in the company, both technical and non-technical, that over the coming weeks and months ahead throughout these sessions you will hear from them. They will introduce themselves and you'll get to know what they can offer you. So I guess I should introduce myself. My name's Robin, or Rob, or you. I've been called worse, to be honest. So it's nice to meet you all virtually. And I'm the technical director at Man and Machine in the UK. I've been with Man and Machine and in the Autodesk channel for 19 years. It's a little over half my life, so quite a long time. And I love the software. I love all things technology. I'm a self-confessed geek, which you probably can tell by my excitement of being live to you now over YouTube. But I don't specialize in any specific piece of software, but you will hear me talk about Inventor. You'll hear me talk about Fusion, Revit, AutoCAD, Vault, Autodesk Construction Cloud, and more. I'm a bit of jack of all trades from that perspective, and I can't wait to share some of the tips and tricks with you over the next few weeks and months. So without further ado, let's just get into something today and just show you a little bit of what these sessions are all going to be about. Again, I haven't really got anything specific lined up for today. I'm just going to show a few tips and tricks, things that some of you might not be doing. And we're going to focus on the manufacturing space inside of Inventor, and then a general tip and trick inside of AutoCAD. So without further ado, let's figure out this massive button box that I've got in front of me here, make myself go smaller, fantastic, and share my screen. Oh, I love technology, it works great. So I'm inside of Inventor 22. And firstly, for those of you that have not updated your software recently and are on an active subscription, this software now in 2022, it looks fantastic. So I'm running this in the dark mode. It really helps your eyes when you're staring at the screen all day to run it in that dark theme. So firstly, that's fantastic. But also, you may have noticed the past few years, the clarity of the model and just how nice these things look when you turn the graphics up on your machine now. You've really got something that looks fantastic, and it doesn't strain your eyes so much with the dark mode turned on as well, which is great. So I'm going to show a couple of things in Inventor, things that we don't see that many clients or users getting the most out of these tools and features, and they're there to help you. So I guess I wanted to share some things with you and just see if they're of use and if they are great. If they're not, give us a comment, give us an email, drop us some feedback over on LinkedIn at Man and Machine, and we'll make these sessions as interesting or specific as you need them to be. But the first thing I'm going to show you is bolted connection. It's, yes, a widely used tool inside of Inventor, but actually there's a lot of new users out there that might not have been shown it as part of a training course, or you might be creating your nuts, bolts, washer connections completely manually. And this design assistant is sat there inside of Inventor to really try and make this process straightforward and easy. And it also taps into Content Center as well. So I've got a simple flange and gasket assembly here that I've literally just thrown together about 2 minutes before we came on air. So it's just a couple of simple revolves, nothing complicated. But what I want to do is connect these flanges together with a bolted connection. So within my assembly environment, I'm going to go to my design tab, and we have a whole wealth of design accelerators on here for creating frames, for creating shafts, spur gear assemblies, belt-driven assemblies and things like that. We're going to focus on bolted connection today because A, it's the simplest for our first session, just to give you a taster of what this is all about. But also, again, it's underused. There's people out there that aren't using this. So let's start it up and show you what it can do. It's really straightforward and it can potentially save you a hell of a lot of time. So when we're in our bolted connection dialog box, we essentially get a few different options. We can place those bolts on a linear XY dimension if we want to, concentric based on a spherical edge or something like that. I'm going to say that I want to pick an existing hole. Okay, I choose a start plane, which is going to be the top plane where the head of the bolt sits. So that's going to be this top face here. And then I can pick my existing hole. So I can go and grab a hole. You'll notice it recognizes what's happened with my model. So because I've built this from a hole, using the hole command and then patterned it, it knows that all of these are linked back to that original hole. So I go and select it. I'm going to ask it to follow the pattern, and I'm going to go and pick a termination plane underneath just here. What that will do instantly, as you can see, is a couple of things. So firstly, it gives me a preview on all of my holes saying, well, that's where I'm going to place these bolted connections. And at the moment, it's previewing that in red. Why? Well, what it's doing is it's saying, based on what you've selected at the bottom, which is using an isometric profile, 14 mil diameter, it needs to drill a bigger hole. And based on that, I think these are 15 mil holes here rather than 15 and a half. It's telling us it needs to take away geometry or volume from this model in order for that to fit. So it's going to drill additional holes in here. Which is great, and we can come in and chop and change that as we see fit, but I'm not going to. I'm going to say, great, do what you need to do and take away the excess material from here. On there, we've also got this add fastener. Now, the first time this loads, it's going to be a little bit slower than the second and third time because it's referencing my local content center from my database. And what I can do is, because I've selected the very top part of that tree, is I have to select my bolt. So I'm just going to go in and select this hex head 4014 ISO bolt. After that, it gives me the ability to add a fastener underneath, like a washer, for example, or I can come and add a fastener underneath. I want a double washer setup, so I'm going to select an ISO 7092. And then at the bottom, after all of my holes, I'm going to select another washer. Again, I'll pick a 7092 ISO washer before eventually picking a bolt. And we're going to pick a 4161 ISO M14 nut to fit on the end. This gives us a little preview. We can change the length of the bolt if we want to, either in the window up here, or just by grabbing this and eyeballing it. So if you want a little bit of excess there, we can. Or if it's got it too long and you want to take away, again, you can. I'm just going to put a little bit of excess on there, on the end of the bolt, like so. Before we go ahead and create this, there's a couple of other buttons in here which really make your life easy. We have a save button and a file naming button at the top right. If we go to file naming, it allows us to control the names of these components as they get placed into the model. But what I want to do for now is just hit export template and save this as an XML file into my workspace, which means I can open that and reference it and use it over and over again. If there's several common bolted connections that you use with the same bolts, washers, and nuts, we can configure them, save them, even put them into our vault if we want to, get them when we need them, and just say open within this environment to save us having to reference them every time, which is fantastic. Other things that you have in here is the ability to come down and have a look at calculation, to get it to give us some basic hand calcs on that particular bolted connection to determine whether or not those components are going to be up to the job of connecting these systems together. We've also got some base fatigue calculation that we can go into again if we want to after that, which again just looks at hand calcs and seeing if those nuts, bolts and washers are up to the job. So if I just hit calculate on here and bring down my notes, we can see that it's missing some input essentially against those components. I've not put any particular forces on there, but it helps you as a designer go through things that you might be doing by hand and really automates them through the system, which is great. If I hit apply, Inventor will pull those models from your content center, and once it's done that, typically the joy of live demos, it's going to crash on me. Don't you love it when that happens? Let's just try that again. By hole, start plane on there. The existing hole we want is this one, and then we want to have a follow pattern termination plane underneath. Thank you very much. Now, if my friend was still here, he would say that the demo ghost is after me, which is a little bit annoying. Something is definitely amiss somewhere, and I can't figure out what. It's that they're there. Ah, okay. Something's really gone amiss, and it's fallen over, which is great. Let's just take all of those off and try that one more time. My apologies. These sessions are not to show you issues; they're to show you things working. I think we've got a rigid constraint in there that looks like it's broken for some reason. Let's have a look at that. Okay, we'll take him out. So let's try that again. Design a bolted connection by hole. There's my start plane. There's my existing hole. We want to follow the pattern, and then the termination plane is underneath. Well, I really don't know what's happened there, which is great. Let's just do a few undos. Hit save. Try that one more time. I will only try it one more time rather than labouring the point. Clearly, I have an issue somewhere with my connections. There's my hole. Thank you. Follow the pattern. Termination plane underneath. See, you really just wanted to see this several times. It was all on purpose, honest. So let's just quickly add those back in. I can use the template that I saved earlier. You see, now you don't know if it was done on purpose or not. I saved the template. Maybe I just wanted to show you the template being used. We'll go with that, shall we? So there's my template. Hit OK. And once again, Inventor does not place those nuts and bolts in the right place. It's failing on the constraints, which is very odd, actually. So apologies for that. It's not really showing that off very well at all. But what they should do is take these nuts, bolts, washers, what have you, and place them constrained next to those components, which I am just going to show you it on a component on its own, just to prove that I'm not going mad, unless, of course, it is my install, which it could be. Let's save that away. Assembly 3, fine. OK. One more try. Bolted connection on the top, by the hole. Choose a termination plane underneath. Follow the pattern. Bizarre, it's not picking up the hole. Definitely something untoward going on there. Not quite sure what it is. My apologies. We'll show bolted connection again next time rather than labouring the point. But that will give you a bolted connection between two components, which you can then set up and use as necessary. Now, I see the problem. I've got several holes in that component. Why have I got several holes in that component? Go back. It's going to annoy me now, so I'm just going to keep doing it until it works. If I shout it for long enough, it will work. Follow pattern, termination plane underneath. Great. Open, bolted connection template, make it a bit smaller. Close your eyes, press OK. Clearly something wrong with my Inventor. Sorry, chaps and chapesses. That's not worked quite the way that I wanted to, so that's a really good start for the first one of these. Let's close that down and go back into the main assembly, because the second thing I was wanting to show you is interference analysis. So Inventor, believe it or not, has an element of clash detection that's sat inside. Hopefully the demo ghost won't get me again this time. He might do. He likes to get me. But What you can do now inside of Inventor, well, I say now, for years, this has been active functionality. We can run some basic interference checking to see if I've got any self-intersection or clashes between parts. So whether you are in a part environment or an assembly environment, I can hit my Inspect tab at the top, and I've got some Analyze Interference. We basically choose two selection sets. I can do a window selection set for set 1, I can do a window selection set for set 2. For the purpose of this, I've got a pre-made clash, so I'm going to clash between the first part of the flange here and the gasket underneath. I've just realised why the bolted connection didn't work. It's the same part twice. Therefore, the hole that it was drilling through, it was trying to drill through twice. I'll show you that fixed in a second. That is completely and utterly my fault, not the software. I take it back. Chair, keyboard interface problem. So choose my selection sets, hit OK, and this will go away and show you and highlight any contact. Essentially on this gasket, I've just pulled up a thickened surface by a few millimeters. But nonetheless, you can imagine if you've got a massive component or a massive assembly here, we can quickly identify and pick up interference. And it will highlight that and show you it in bright red in the model and give you some information which can be printed out as well. That can allow us to go and find that gasket, find the particular problem. In this case, it was a thicken. If I turn that off and once again analyze interference between those two flanges and hit OK, we get the problem resolved. So don't forget that you've got that analysis or the analyze interference in there, which can really help you. The final thing in Inventor that I wanted to show you is just reminding you of this marking menu that's been commonplace in Inventor now for 10, 11 years, maybe a bit longer. This thing's great, and still people aren't necessarily making the best use out of this right-click marking menu. And to show that, if I just start a new part, what happens when you right-click with that marking menu is you get these segments, whether you want to call them segments, wedges of pie, wedges of cheese. Let's go with segments. They are there, and they allow you to basically be very inaccurate when you come to click. Which means this bungee, as you pull off, is basically hovering over that fillet command wherever I click within this section. So if I click up here, it starts a fillet. If I click down here, it starts a fillet. What you can also do is do this very quickly, and naturally the marking menu will update. So if you hold down your right-click menu, don't let go, hold it down. When you move, for example, if I move downwards to New Sketch and let go of my mouse, it invokes the command. What that means is quite quickly, if I just click, hold, drag and let go downwards, it starts a new sketch. I can then create a sketch on the front plane. If you look at the marking menu in the next screen, it's changed to context tools. So I see sketch tools. So if I do the same thing to the top right, click, hold and drag to the top right, it gives me a 2-point rectangle. Click, hold, drag to the right is OK. Down is finish. And then, where's extrude? I can never remember extrude. Top right, click and drag to the top right, you get extrude. And then to the right is OK. What that allows you to do, and you'll probably find this happening naturally, but you can actually come in and say, new sketch, 2-point rectangle, OK, finish sketch, extrude, without even stopping to think or blink, essentially. So you've got some speed improvements there. That's neither here nor there until you find out that that marking menu is fully customizable to have your own right-click options. So if you've not seen it, head to Tools, go into the Customize dialog box, and in here you've got the ability to customize your ribbon, the ability to customize your keyboard interface, and the ability to customize your marking menu. What I really like about this is you've got all of the different environments that you can come in and change. So I'm currently in a part, so it's automatically selected the part environment. But then we've got this, this sub-environment. These are all the default ones. You can actually add your own, which is a control and right-click menu, which is completely blank, which means if I hold control and right-click, I can get access to tools that I otherwise wouldn't have on my marking menu. So for example, let's go to the right-hand side and say I want to find material. I'm going to drag my material and place it over here. I want to find bill of materials and put it at the top. I want to find create drawing view and put it on the left. And then maybe I want to find save all and put it at the bottom. Ooh, sorry, my mistake. So you first select the wedge that you want to affect, and then create drawing view. There we go. And then you click the object that you want in there. If I hit apply, again, you can export and import these to save them across machines. Hold Control, hit right click, and you've then got that custom marking menu just there. Again, little things like that, they enable you to really go quite quickly and really get tools in there that otherwise, you're up here figuring out where it is in the ribbon, or you're scrambling for the keyboard shortcut. Your mouse as a designer wants to be here in the middle of the screen, not up there. So that's a really nice tip for you inside of Inventor. Now, I don't want to leave Inventor with it beating me, so I'm going to try this one more time. I am determined to get a bolted connection working today because they are the easiest of easy things to work, so why it's not, I don't know. So let's create a simple plate, 12mm thick by 250. And I know for a fact when I get back upstairs, one of my colleagues is going to say, you didn't do this, which is why it didn't work. But that's the fun of these sessions, right? So let's say, save that, place it there as part 8, and we're just going to put this into an assembly. Try that good old bolted connection one more time, just to make sure I'm not going mad. So let's place in part 8, as we did there. Lovely. Press OK. Great. Design, bolted connection. I need to save the assembly. That's fine. I'm happy to do that, so long as you work this time, Inventor. We don't have a concentric point or a hole, so I'm going to say linear reference this time. Starting there, linear edge is here, 55. Linear edge 2 is here, maybe 105. ISO profile 14. That gives me the location of my hole. From that point, termination plane is underneath. Termination plane is underneath. Come on, there we go. Termination plane is underneath. There's my hole. Let's open our bolted connection template one more time. Press OK. Hooray! We have a bolted connection. I suspect there was something that I clicked wrong there, so my apologies. As you can see, if I drag that bolted connection around, it's fully constrained. If I ground part 8 here, grounded, bolted connection is constrained apart from the spherical face, which is great. It's physically locked with regards to its movement, apart from the rotation, which is fantastic. So if that had worked first time, I'd have been saying how bolted connection is great and it's saving you loads of time. As it is, you're probably looking at that and thinking, well, it didn't work. So hey ho, but take my word for it, it works fantastically well, especially when in an assembly. So they're the tips I wanted to show you, Inventor. Appreciate you're not all Inventor users, so I'm actually going to end inside of AutoCAD. So inside of AutoCAD, I've just got one half of the flange that I had inside of Inventor, and I'm just going to share with you my single most favorite tool inside of AutoCAD, and I think it's great. And that's the oops command. I'm sure you've all heard of the oops command, but when I train, or when I used to train, I was quite surprised at how many people didn't know it. So let's take this edge here. I'm going to delete it, but then I'm going to continue working. So I'm going to go and select all of these components here, and this edge. And, yep, good. And I'm going to mirror them. I'm going to mirror them around the center of the gasket there. So snap overrides mid between point and point, and let's mirror it that way. Erase the source objects. No, I want to keep those. Oh, I've got a gap here, so let's put a line in there. I must have forgotten to select one. Oh, that's on the wrong layer, so let's be naughty and put it on layer 0. Don't tell anyone. And let's carry on working. So let's draw some really detailed geometry over here, such as circles, triangles, squares, and lines. Oh, we've got a problem. We deleted something earlier. I know it's only a line in this environment, so it's not a problem. But imagine you've deleted a block, or you've taken out something by accident, and that deletion was 15 minutes ago. If you type in oops and press enter, it will... Nothing's working for me today at all. Oh dear. Oops will undo your last delete. No matter how many things you do in between, if you type in oops, it will undo your last delete. Apart from, because I'm doing a YouTube live, it's decided it doesn't want to undo my last delete. But there we go. What oops will do is it will take the last thing that you deleted. It doesn't matter how much stuff you do in the interim period. We can go on here and do whatever we need to. If we type in oops, it will bring back those components previously deleted. And that technically, apart from being a bit of a shambles, was all I was going to show with you today. Just to give you an idea of the kind of flavor of these sessions. Tips, tricks, things inside of Autodesk software to hopefully help you day to day. I'm now going to go and throw my laptop out the window and run over it in my car a few times. And hopefully next time we do this, next week on Monday at 2 o'clock, hopefully it will behave itself. So again, I hate to pry, but please like our page, subscribe to us on YouTube, visit us on LinkedIn, give us a comment, hit the bell to subscribe, and you'll be able to keep up to date with these live sessions. But there's a wealth of knowledge on our YouTube channel, standard demonstrations, as well as, let's just make myself a bit bigger, there we go, standard demonstrations, tips, tricks, you name it. So check them out, leave us some feedback. Thank you very much for your time. Been a pleasure. Sorry for the issues, but until next time, take care. Don't get blown away in the wind tomorrow. Stay safe, and I'll see you soon. Thanks a lot. Goodbye.